Now, let us go for the another application, that is the third application. Basicity or basic property of aromatic amines. Aromatic amines. So, already we have discussed the ammonia is a base. We have considered this as a base. Ammonia has a lone pair, so it can donate a pair of electrons when it is HCl and this is together added. So, this gives a pair of electrons to the H plus and you will get immediately ammonium chloride salt formation. So, ammonia is an electron donor. So, therefore, it acts as a base. So, that there is no problem in understanding ammonia as a base. Now, we have any alkyl group attached to the ammonia. This alkyl is a saturated one, alkyl group. A saturated, a methyl or ethyl, whenever such groups are attached, the alkyl group shows plus I. So, arbitrarily we have fixed alkyl as a plus I, and conceptually also when carbon is attached to the nitrogen, nitrogen is pulling. So, therefore, carbon is donating. Not because of the excess, but the electronegativity difference between the carbon and nitrogen, that is pulling. So, therefore, this is pushing. So, you can divide that or consider the alkyl group as a plus I. When the plus I groups are attached, the original donating capacity and additional donating capacity because of the alkyl. So, there is some induced, some extra property is nothing but the induced property. It is not exactly the sigma bond polarization, but slight deviation in the explanation you see here. It is not the bond polarization here we are discussing. The ammonia has got a electron donating property. Because of the plus I, the donating property is increased. This is the increased donating quality is the induced property now. So, this we exactly term as a inductive effect. So, there is increased electron donating quality, therefore, I call it as a stronger base. Now, coming to a benzene attached amino group, right. So, in this case we call this benzene as an aromatic one. The name of the compound is however, we can call it as a phenylamine or aminobenzene, benzene with aminobenzene. Okay. But in this case what happens, the phenyl, whether it is donating or withdrawing, with reference to the lone pair and the pi bond, they are in conjugation. So, therefore, instead of the inductive effect, a better tool, inductive effect is a weaker effect. Now, using the resonance, if you write, so the lone pair is given like this, it is accepting, and so therefore, we can write the resonance of the aniline. So, in the aniline, common name is aniline. Is the aromatic compound, commonly aminobenzene is called aniline. So, this aniline you can write the resonance structure in which the NH2 now becomes a positive charge and the minus charge is there on the earth position. There is a double bond between the nitrogen. Now, can this donate a pair of electron from the nitrogen, means in this structure there is no lone pair at all. So, therefore, only out of the two structures, or in fact it is continued. If this is given, this goes to the here becomes minus. If that is given, this goes here, and so out of 1 plus 3 resonance structures, only one structure is having the lone pair. Rest of the 3 structures, the nitrogen is having a positive charge. When there is no pair and moreover positive charge, how can it donate the electron? So, therefore, the basic quality of the aniline is almost totally vanished. So, very small basic property is found. That is why the aniline is found to be a very, very weak base it is. Okay? It is a very weak base it is. So, therefore, altogether you can write now any aliphatic amine, if it is there, which is found to be a stronger one than ammonia. When compared with ammonia, all aromatic, let us designate as ARNH2, the common amine, aromatic amine. Aromatic amines are very much weaker. You too can emphasize a point that using 2-3 arrows, aromatic amines are too much less weaker. So, it is strong base and very weak base. Why it is very weak? Because the effect is very strong. Here only density is pushing. Here the real electrons are withdrawn. That out of 1 plus 3, 3 structures have no lone pair. So, only one structure has a pair. So, therefore, the aromatic bases are very too much weaker bases. Now, the examples, simple example is a methylamine is a stronger base than ammonia, than a benzene with the NH2. Phenyl NH2 is a simple example, aniline, right? This is a NH3. You can little better question can be asked like this. Now, the question is, a benzene type of NH2 is there, and this is stronger than the benzene with NH2. Now, the little confusion is there. Both look alike. Okay. Only the difference is here this is aromatic, this is non-aromatic. Now, the moment you see the confusion is alike structure, here it is clearly that is the ring, this is the non-ring. Now, the question has become little confusion. Both there are rings are there, but the effect shown by this saturated system is plus I. This is a double bond is conjugation with the lone pair is a minus M. So, you must be able to clear that through this phenomena. So, one group shows plus M plus inductive effect. So, this saturated system shows a plus inductive effect, aromatic system shows a minus mesomeric effect. The question also can be shown in a little more in a way. Aromatic, let it be, but attached through the NH2. This becomes still it is a plus I group only. This is an aliphatic benzyl amine. The benzene with NH2 is phenylamine. Benzene with CH2 is benzyl. So, this is a benzyl amine. The comparatively this is stronger one when compared with a benzene with the NH2 I will write, but I will put a CH3 this side. Both will become now isomeric, both are isomers. Number of carbon benzene 6 plus 1 7, 6 plus 1 7. So, when these two compounds if you taken, here it is plus I effect, here it is a minus M effect. This is a paramethyl with aniline, this is called aniline with methyl. If methyl benzene is toluene, this is called paratoluene. Paratoluene or paramethyl aniline, okay, para-amino-toluene, commonly known as paratoluene. Look like very much because number of carbons and all that, but the phenomena is exactly reverse. One is a positive effect, one is a negative effect. Even the question can be much more, little more complicated. See that there is a benzene attached with another ring. In this ring, the nitrogen is on the first, okay. However, one hydrogen will be there. When compared this compound with another compound, again benzene is there, but in the ring the nitrogen is on the then next carbon. Now, out of these two compounds, this is an aromatic compound, isn't it? Aromatic means lone pair is taken and the ring undergoes like. So, here minus M effect is influencing. Here the benzene cannot show resonance with the lone pair, only inductive effect, plus I effect. So, this is the stronger base, this is the weaker base. Both look alike, very much close, both are benzenes are there, both are NH groups are there, but the lone pair when it is conjugated, then only this minus M effect comes. Here lone pair is separated by 2 sigma bonds. So, this lone pair cannot show resonance. Resonance comes within the benzene, that is different. But the benzene, this pi bond and the lone pair cannot show resonance. So, that is detached system. So, therefore, that lone pair will keep quiet, and in addition this both the sides we have a 2 alkyl groups are there, it is a 2 degree amine. Here only 1 plus I, 1 minus M is acting. So, the minus M and plus I examples these two. So, therefore, a given example can be if you carefully understand, it is not just inductive effect, but sometimes mesomeric effect is coming, and that mesomeric effect is a reverse to the inductive effect. Mesomeric effect is minus A and the plus I is inductive, introducing electron donating group, that is the withdrawing group. So, total basicity will be reverse. So, usually a huge number of questions can be set on this particular aspect, but carefully observe that when aromatic system is attached to the amino, aromatic system is acting as a minus M and the basicity is decreased. Similar the case even amides. When amides also, if you discuss, R with NH2 is a stronger base compared with the ammonia. But when R with CONH2, this is called acid derivative of this one. The CO shows a withdrawing quality. There is a lone pair that is withdrawn. So this RCO is a minus M group you can. R is a plus I group. So amines are stronger bases, or 1 degree amines in fact, are stronger bases than ammonia. But when come to the amide group is a minus M group because the lone pair is withdrawn and the CO pulls. This CO is much more stronger than the CC double bond. The CC double bond also pulls because there is a richness it gives and it takes. Here there is a polarization, original polarization, therefore strong pull will be there. So amides are very weak bases and almost the basicity is 0. And in some cases specifically when the two sides amides are there, this side amide as well that side also amide, they are called imides. In such cases, two minus M effects are influencing too much, both the sides minus M only, both the sides minus M, double minus M effect. The lone pair will be either this side or that side. At any time it will be withdrawn only, and oftenly the charge will be there. In the resonance structure you see the nitrogen will have a positive charge. A positive charge containing nitrogen with a proton, the proton is given out as a H plus. So it too develops a acidic property also. It is not only basic, weak base, but it has an acidic quality. Even in the aromatic phthalic acid amide also you can note this same effect. It's in both the sides amide called phthalimide. This hydrogen shows acidic property. Actually, it's a nitrogen derivative holding a lone pair. It should be basic. But the basic quality is withdrawn by the 2 minus M effect. So it has come to a ground level. And then because of the double effect, the basicity is much more decreased and reached to an acidic quality also. This is called phthalimide. Phthalimide is acidic. That's why it is soluble in the potassium hydroxide. A salt of phthalimide, potassium phthalimide is available. That is reacting with base shows it is acidic quality. So amides and aromatic amines are having minus M effect, therefore the basicity of the nitrogen is totally decreased, and we can note in some cases even acidic quality is also generated.